Hi, welcome back on the Pumpkin Hell beginner series. As few of you made me notice in the first part, well, this isn't for complete beginner who is starting CG from ground up. Still important to have maybe some background in other 3D package or general knowledge. Be able to move in UI, that kind of thing is essential if you want to understand this series. This part 2 is about Lookdev using Solaris, so I will be using the latest update in Houdini 18.5, so a couple of new features should help us in this fun task. Now let me say, if you are not familiar with what is roughness, specular, subsurface scattering, well, that might be a problem if you want to understand this tutorial. If you haven't seen the first part about modeling, maybe give it a try first, or if you're just interested in Solaris, well, that's okay. Take a cup of coffee or tea, sit back and let's dive in. So in this first step, let's import our model into the stage of Houdini. So as you can see, if we dive inside our pumpkin, there are a few things we want to address so we can split in different materials. We have some attributes and groups. We had this thickness and inside attribute that will help, but we got some useless groups. So we want to create a group just for the stem. So we'll call that group stem. And we can copy it and just create a group for the skin that will be pumpkin. And yeah, that will help us splitting some elements and assign shaders a bit more easily. Now, we want to get rid of the useless kind of group that we created along the way. Let's say we want to delete the patch group. Well, this is gonna get rid of this patch group. It's pretty easy. Now, if we want to delete all the groups, we can use a star like this, and it's gonna delete all the groups. Now, we could do that, but say except using this sign, stem, and do the same for the pumpkin group so that we keep just those two specific groups in the data of our asset. So organizing your asset and optimizing what's needed or not is something pretty important, and especially when you are at the Lookdev phase. So let's check out. I did the same for the pumpkin A, and now we are ready to jump into the stage. So we want to switch the UI to Solaris, and we got some new panels showing up. And what we want to do is, well, let's get rid of this panel for now. We'll reduce it, and we're gonna go and change the context to stage, which is where the magic of Solaris happen. So we'll use a SUP import to actually import data from the geo context. So let's fetch the output of our pumpkins. So in that case, output pumpkin. And as you can see, we got these showing up in this graph. The name is basically driven by the $OS expression, and $OS is basically the name of the node. So if we change to test, this is updating in this graph. And what we want to do is extract some groups. Let's load as reference. Now, the primitive path, it's pretty important. It's like a way to organize your hierarchy inside your scene. Think of it like the outliner inside Maya or Blender, basically. You can structure in groups, control the shapes and so on. So this is pretty similar in that way. Now, you want to organize things in a way that makes sense. So it will depend on pipelines and stuff. All of these, we got different kind, like group components, subcomponents. So it's a way to organize USD files and heavy scenes. So for now, let's just get past the name and work on the Lookdev. So we're gonna copy this SUP import and just try to import a group like the stem. So we wanna isolate it. We'll call this primitive path pumpkin stem A. Now, we want to also isolate just the skin or the meat of this pumpkin. So let's do that here. And we'll merge those two elements. So maybe it's a bit weird because you're like, okay, we just got the same result, but we have this split into our scene graph, which can be important for scene organization. And you'll see in a sec. So we're going to import the second pumpkin. It's called pumpkin B. That's great. So let's add up the name. That will be stem B. And let's do the same in the other node. That will be mid B. And yeah, we got our other model, bring into Solaris. So let's merge those. So as you can see right now, they are all under the same pumpkin geo hierarchy. And let's say we want to try to move the pumpkin A. So we can use a transform. So let's try actually here. Oh, let's try to move this. And as you can see, it only moved the skin of the pumpkin, even though the stem was merged. So it's a pretty different kind of mindset when it comes to stage. And you want to understand that the primitive path is very important in that way. So one way to fix that could be to add this hierarchy in between, which would be pumpkin A. And let's get rid of the A in the end. So that would be pumpkin A and pumpkin meat. Now the transform, we got, let's see, if we merge, we have that under the pumpkin A. And what we want to do is grab the pumpkin A and drop that into the primitives. And it's now moving everything that is under this hierarchy. So there might be some other ways to do that, of course. So let me know whatever you think is the best way. And in here, we'll actually do the same and insert hierarchy in between. Let's say pumpkin B. So we'll do the same here. Okay, let's check out. Now our scene graph is much more organized, let's say. And we could add a grid to our scene. I'm just gonna add this, that will be our ground or floor. Yep. It's now time to create and assign some basic shaders. So the most important node here is going to be material library. It will contain all our shaders. So in there, you can dive inside and create materials like principal shaders. If you are familiar with Mantra, it's exactly the same thing. And we'll call that ground. Let's copy it. And this one will be for the stem. And we'll change the color. Something like, not probably green, but some kind of bright brown. Now for the pumpkin skin, that shader will require a bit of work, so we'll use a material builder to do all our network inside. So we'll build our own shader for this one. So we'll call that pumpkin skin or meat, I can't remember. And actually let's call that pumpkin stem so that it's a bit more clear. Okay, so inside the pumpkin skin material builder, we have these nodes. And what we want to do is start creating some shader. We'll use a principal shader core, which correspond to a way to layer or stack shaders together. So we'll call that skin. And this would be for the inside of the pumpkin. So we have two different material for the skin and the inside. And I'm gonna bring a constant value that will control the color. So we can control it here, of course, but I like to actually have an external node, let's say, to control and manipulate this color later on. Okay, something like that for the inside. And for the skin, we'll go for something orange. So let's pass this constant. And we'll go for orange, probably more saturated. All right. Now we want to mix them together. So we'll use a layer mix. So we'll plug the skin inside the A input, which correspond to the one that we'll see in bottom. And on top of it, we are stacking the inside in input B. And we'll use the alpha to blend them. Now, for the alpha, we want to bring an attribute we created in the first part. So we'll use a bind node to call this inside attribute we created earlier. So let's just bring inside. So this mask, this black and white mask, should help us mix those two shaders. Now, if we try to connect it to the surface output, you can't do that, actually. you would need something in between, like a surface export, just so you can convert your layer mix into some legit output for the colors and stuff. So we'll use those, I think, inside the surface export. Maybe it's not necessary. I'm just gonna do it anyway for now. And let's plug the surface color output, the opacity, and BSDF. Okay, so everything should be connected properly so that we can actually see this shader in action. So pretty simple setup for now. And now what we need to do is assign those material. And guess what's the name to assign material? It's called assign material. Pretty self-explanatory. Now let's connect it. And there's multiple ways to assign materials. So we could just take them out of this outliner and drag and drop them on any surface. Let's say set on this grid component. Let's try on the pumpkin. So that's where it's interesting. It's proposing you different options. So if we drag on pumpkin geo, it will apply on every pumpkin. So we just want on the meat in that case, so that we can apply something else later to the stem. So that will be on the meat of the pumpkin A. So let's just drop on the meat. And the stem, that will go just on the pumpkin stem. If you try to drop it on another level, it will apply just on pumpkin B or just on all the pumpkins. So one other way could be to just drag and drop the geo input that you need, well, just the primitive path and the material path in here. So that's exactly doing the same thing. Time to create a basic light rig and start working on the materials. All right, so the first thing we want to do in this scene is going to be to bring a camera. Now cameras, they work a little bit differently than inside the Houdini, regular Houdini context. So we need to actually merge those cameras with the rest so that we can actually access them. Otherwise, as you can see, we can't access them. It's important they are part of the same node and that the flag is at the proper place so that you can access this camera. Now let's lock the camera so that we can move it based on this view. Awesome. All right, I'm just gonna change the focal length in here and reduce that to 20 so that we got this weird angle that could feel pretty spooky, I guess, for Halloween, so why not? Okay, let's uncheck this lock, and from now we wanna create some light. So the basic light you may wanna use first is a dome light. So things should get a bit more interesting. Okay, so I'm actually already into a Karma view, and by default maybe you are set into OpenGL, which is faster to assemble and stuff. But once you are already set up with light and shader, it's a good idea to switch to Karma to see what's going on. So let's hit D to access the settings, and one thing I like to use is the denoiser. So if it's turned off, you see things get pretty grainy and takes time to get refined. If it's turned on, well, we got smoother result much more faster. And if it's not done and you have an NVIDIA, you can download the NVIDIA Optics Denoiser. At this point, we want to start playing with the dome light. So let's load HDR image. I downloaded from HDRI Heaven. Highly recommend this website. And I'm loading first something that's like not too contrasty, just to see some specular going on and something pretty diffuse, really. That's all I need to start my Lookdev. Okay. So from here, we could also drop a Karma node if we need to do some more like high-res renders, because this would be just a preview. So the camera is automatically assigned, and this would be the final amount of pixel that will be rendered. So if you hit D, you see the amount of sample that is being used in the viewport. So at some point you may want to crank it up just to see more detail going on. Okay, and one way to render is just to press render to mplay. So this is new in Houdini 18.5. And yeah, from there we're gonna start working on the shaders. So the first thing is that we don't see the inside of the material. So I assume something went wrong inside this material builder. So let's get rid of this. And yeah, here we go. We actually start to see some things going on. So if you're wondering why it turned green, no worries, it's just an editing mistake on my side where I was tweaking colors to see a bit more clearly if that was working. So it's back on our yellow color we assigned earlier. So let's set something like that. That sounds about right. So at this point, everything's looking pretty flat, nothing much going on. So we want to start introduce some variations and breakups. And I usually like to use turbulent noise to drive some texture procedurally. So it's looking pretty flat right now because we need to feed position data that we can find either on surface globals. So that would be the P attribute. And you can find it actually also on displacement globals. So let's just connect the position. So at this point, this noise is based on world coordinate, which means if you move the pumpkin, the noise will look different. So I'm adding a bit of frequency. If you want the noise to stick on the geometry, you will need to create a rest position. If, let's say, you have an animation or something. So that's something I talk about in other tutorials. Here is a link if you're interested. Now I'm pretty happy with this noise, so I wanted to drive some variation on my color. That's why I'm using a color mix, and we'll use this turbulent noise as a mask to mix our constant with a secondary color. I think by default there should be some kind of purple looking color. So we have some Thanos color here. And I actually don't want that, so we'll use a color correct to manipulate our initial constant. So you can also feed another constant in there, it's up to you, whatever is easier. In my case, I like to just control some minor variation using this color correct. I'm actually gonna increase the samples in my viewport. Okay, so I like to use these kind of minor tweaks using color correction to bring some subtle variation. So of course you can bring another color, you can feed another color, that's up to you, but in my case I like to use this kind of setup. And we see some little spots, yellow spots appearing, so that's pretty cool. So we'll also use this noise to actually drive some bump. I'm gonna rename that mask. And to drive the bump, we'll use a displace along normal. And what's interesting with this node, not only it's useful for displacement, but also there is this disp_n output that actually outputs some vectors that we can feed into the normals input of our shader. So as you can see, by default, it's pretty strong. It's gonna take a bit of time to refine. All right. And what we could do in Houdini 18.5, we can click here and actually take some snapshot of our renders. Let's wait a bit and let's click on this big plus, and this will take a snapshot of the viewport. So that's a pretty handy way to start the progress and compare things. So definitely reducing the scale of this bump. So it looks like this pumpkin is pretty sick with this amount of bump. We may want to go for something more subtle. Or not, if you want to, I don't know, do a zombie kind of pumpkin, yeah, sure. Why not? Up to you. So we can compare things, just assign a A image and B image and just click, and you can use this line to kind of swipe between your renders. So that's pretty handy to compare things. Yeah. Sweet. So yeah, let's do a last round of changes. Gonna go for something way smaller in terms of scale. So that works better in my opinion. And at this point I will copy this kind of setup for the bump and apply that on the inside shader as well. So let's plug the displacement, normal. Yep. And may want to adjust the frequency, like something bigger and more uniform too. I'm gonna increase a bit the bump for the inside. Okay, let's wait a bit and okay, let's store one result. Okay, let's see. So A, B, that's gonna be the new A, and this is gonna be the new B. New B. Okay. So it's pretty interesting. I would say let's be careful with the bump so it doesn't look too crunchy inside. We don't want it to feel like rock, but more like some kind of organic texture, of course. I'm gonna make some room. You can alt click here to actually create a dot that can help you organize a bit better your graph. All right, and in here I'm actually gonna create a fit range to control the final output of this mask. So if I set it to 0.5, it's gonna reduce everything by 50%. Let's say the bump, the color variation, all of this will be attenuated by 50%, as you can see if I compare. Yep, it's looking much more orange because we are removing some yellow, and also we got less bump in general. So that's great. It's time to try and make a proper render. So I will also output all the different AOVs. So this is of course super helpful for compositing if you need to fine-tune some last minute specular or anything, but also for debugging. It's also a great way to see if we have too much specular, too much glossiness, if the colors are too saturated, this kind of thing. So if I'm not misunderstanding, visualizing the render in mplay is actually a new feature. And you can of course check out all the passes. So as you can see, I actually stopped at like 60%. It's actually pretty slow on my laptop, but still we already get some kind of decent result, and it's enough to check out if our textures and shaders are looking all right. So there's no SSS at the moment, but we're gonna work on that. But before that, I think we still need to do some final changes, like decreasing the bump. That's definitely too much in my opinion. And maybe I'm gonna change a bit the frequency of the inside. So let's go back in the pumpkin skin and decrease the displace along normals that we find for our normal map. Also this frequency, let's reduce that to 6, that will make it bigger. Anyway, by the end I'm looking for a pretty stylized render, so I think that should be a good base anyway. It's time to work on the lighting and get creative. So far we just have one dome light. I'm gonna use a switch so that we can still go back to this lighting rig easily. But what we want to do is create a new, let's call that a light rig. So I'm copy and pasting this light, and let's set that to input 1 so that we are now working on this branch. So I can use a multiplier to actually get something way darker. So I'm looking for something pretty dark, but still having some interesting kind of specular going on. So I think that might be helpful in that way. And I'm gonna create some new lights that will illuminate the inside of the pumpkin. So for this part of the lighting, I will just switch to Houdini OpenGL just to iterate a bit faster. And anyway, the representation is pretty accurate as long as you got this high quality lighting with shadows enabled. And by default, we have a point light. I might try to wanna switch to sphere, I think, in that case. Just so we can control this radius of the light. And I guess the bigger the radius is, the more diffuse that should be. So something like that could work. Now we could work on the temperature, make it look more like some kind of fire. After all, this is called pumpkin hell. Sweet. So we got some pretty interesting shadows. I'm kind of liking this pumpkin so far. Let's try and put the light on this other one. So the mouth is definitely smaller in here, so we don't have such a big impact on this one, I guess. But still, it's pretty interesting. Okay. So I'm actually gonna get rid of this pumpkin. I'm just gonna focus on one. From here, I'm gonna add some kind of rim light, and I'm gonna change it to maybe some kind of disc and move it. So move it to the back left. At this point, it's just a matter of experimenting and trying to find some interesting shadows, some highlights that are looking pretty cool on the pumpkin. So can play with a spotlight angle, play with the softness. We have some barn doors so that we can actually control the sides and top and anything really. So yeah, that's pretty useful in that way. I'm gonna move it a bit higher. Yeah, I think that could work nicely. Let's check out in camera. So I'm gonna adjust a bit this camera though. So something more like that and more. Oh, that's too close. Oh, something like that's pretty interesting in my opinion. Well, feel free to get creative and make your own version. So the orientation of this pumpkin now is not feeling so natural. So I'm gonna grab this pumpkin B, drop the path here, and let's manipulate the rotation a little bit. Yeah, something maybe more like that. At this point, I want to start checking out the result in Karma. Let's see. So that's a pretty spooky look already. Now, I want to do some changes. I think I cropped too much of the left barn doors. So, oh no, right barn doors, my bad. So we could also play with color temperature. Where was it? Oh yeah, softness. Okay, I'm pretty happy with that. Now, one way to control the lighting, you don't need to switch from one light to another. You could also use a light mixer. Now, to use a light mixer, I would recommend first to name the light that you are using. And now you can drop a light mixer after the merge. Let's set the flag on the light mixer, and we can drag and drop the light that we want to tweak, expose some parameters. And what's pretty interesting is that we can control everything from here. We can create some kind of set. So could manipulate a bit more this one, and we'll probably reduce the one inside the pumpkin. So it's actually very easy to balance things out and see what works, see what doesn't. You don't need to switch from one light to another. So I'm really liking this way to work. Actually, I'm gonna expand a bit this graph. Yeah, that's easier to tweak things, I guess. And yeah, you can control the colors. You can go back to this attribute tab and change color temperature. In transform, you can store different position, I guess, for the lights if you want to try different settings. So yep, light mixer. For me, it's one of the highlights of using Solaris. So before moving to the atmospheric part, I'm gonna store this render just so we can keep track. And we also need to work on the subsurface scattering on this little guy. So maybe I'm gonna do that first and head into the material library The pumpkin skin, we're gonna start adding some subsurface. By default, the subsurface distance is set to 0.1. We'll see, but that might be too much in our case. So subsurface is the amount of subsurface you want, and the distance will be how deep do you want your light to spread within your geometry. So we'll use the thickness attribute that we created in the first part. And well, this will act as a mask that we're gonna plug inside the SSS input, so the global amount, like so. And let's plug it as well on the skin. So if we compare now with what we had before applying this subsurface scattering, so this was feeling too hard and that's now feeling too soft, I guess. It's more like a wax kind of look. So yeah, we probably want to reduce the SSS distance. All right, so let's dive back in the pumpkin skin and we'll create a constant float. So let's actually grab a constant. I'll apply a color just so we make a distinction with the others, and that will be SSS distance. So let's plug it at the right place for both shaders. Okay, so can even do a little network box if we want to remember that this is the SSS control. So it's usually a good idea to rename things and make things nice and clean if someone's picking up your scene. So yeah, don't do like me. So we'll set this distance, this SSS distance to 0.05 for now. I'm gonna store this result. I think that might still feeling too much, so I'm gonna decrease to 0.01. In that case, I probably reduced too much, so something in between. Let's say 2.5. And I think it's in pretty good shape now. Yeah, I think that's looking much more subtle at this point. Yeah. Moving on, it's time to work on the atmospheric of our scene. So let's set that back to OpenGL, and it's time to leave the Solaris mode for now. So back in regular Houdini, we're gonna create a fog volume that we can use in our scene. So sometimes you can have some VDB from other projects and stuff. In that case, I'm gonna make something from scratch, something pretty basic. So we'll use a tube that we're gonna fill with some volume. Not using a box, just so we don't see the corner of the box. So in that case, a tube maybe is a better idea. We'll see. So want something that fit the size of my scene. We don't want something too big because it could get pretty heavy anyway. And I'm gonna fit the tube above the grid. So this way, if we tweak the height, it's staying above the grid. So we'll set a higher number of colon and end caps to close the geometry. So from there, we are ready to convert that into a volume using our VDB from Polygon that we started using in the first part. The difference is that instead of using the default mode, which is called the SDF, we'll use the fog VDB. So this will be a foggy element for our scene. Now, this is feeling very compact. The first thing we'll do is decrease voxel size. This value will depend on the scale of your scene, of course. So adapt it if you need to set it higher or lower. And we'll use a volume VOP. So in previous part, we've been using point VOP, and this is actually the same kind of idea. Instead of having a geometry output, you got volume output, and you manipulate the density in this case. So we'll use a relative bounding box to extract bounding box information and be able to remap, let's say, the y-axis or the x-axis. So a vector to float is a pretty nice way to extract the x-axis. So it's going to make a gradient based on the x that would be based on the y, and the third input would be on the z. So if we plug the z, we got a fall off going in the z-axis. So we may want to remap those values, of course, because right now this is not going in the right direction, and using a ramp parameter will be easier to manipulate our density. So density is a float, so I'm setting that as spline ramp. And yeah, you can change this ramp above. So you'll access here and can tweak this to control the look of your fog. So let's extend the graph so that we see a bit more clearly what's going on. And we're going to set that as B-spline just to make it smoother. And yeah, I think from here it's easier to manipulate the fall off. And we obviously want to integrate some variations. So we'll use a turbulence. So that will help give some kind of smoky vibe. And if we try to check out the look in the final density, well, everything is getting controlled by this noise. And we can adjust the frequency if need some smaller details, or reduce it to get some broad kind of shapes. So I'm going to use a fit range so that we can contrast this noise and get some more clear distinction in this volume. So you see, if we contrast too much, it's almost looking like some kind of clouds. But anyway, what we want to do is use this turbulence as a mask to remap the height of our fog and get more interesting things going on. So let's drop another fit range and we'll connect that to density. As you can see, if I play with the source min, it's now controlling how much do you want to decrease this volume. And basically we could use these values to feed into the source min to drive this height difference. So now it's a bit more interesting because we get some more compact things in the bottom, but still get some interesting breakups on the top where you have this fall off going. So we need to fine tune a bit this turbulence, I guess, to get some more interesting effect. Okay, maybe my frequency is a bit too high. So we'll promote those parameters in a way so that we can control that outside this volume VOP and just access that upstream. Yep. So actually I'm gonna adjust that and try to get some more fall off. Yeah, that might look a bit more interesting. We'll also expose the turbulence frequency. We'll expose the offset. So some kind of basic control so that we can quickly iterate. I'm much more happy with that. And if we try to change the height, well, our volume will adapt accordingly since we are based on the relative bounding box. Okay, time to export this. We'll create a file cache so that we don't need to compute this volume all the time. So we'll store that into geo and call that fog and save to disk. Don't forget to load it, of course, and we'll create an output to load into the stage. Output fog. Here we go. I'm gonna rename this node just to make this clean. So that will be fog volume. All right, let's go back to the stage. Actually, let's drop the Solaris in UI and here we go. I'm gonna go in the stage. So to import it, I will just use SOP import. And just like before, we'll go and fetch the output of our node, the output fog. Okay, let's add that in our scene. And we already see some OpenGL display. We'll use a transform to manipulate this fog, move it around. I think I'm gonna set it lower. All right, and can probably try to scale it down. So fun stuff. Okay, so at this point, I want to check out how it's looking with Karma. And it looks like the lights are properly affecting the volume, so that's great. And I'm actually gonna consider tweaking a bit this fall off. I think I reduced it too much. So heading back on our volume VOP, and we're gonna adapt this ramp just to make things a bit more compact at the bottom. So let's save this change. All right. Let's go back to Solaris. I think it's gonna look a bit better already. And let's store this result. And yeah, I'm pretty happy with that. I would say we could fine-tune a bit the ground. We didn't touch the shader, so I'm just gonna make it darker and decrease the roughness so that we get some sharper reflection going on. Yeah, I'm gonna store this result. Yeah, I think it's a bit more interesting. All right, so pretty happy with that. Just one note, let's go back in OpenGL for a sec and display the settings. You have this fog tab now. I don't think it was here before. And if we remove this fog for now, you see that we have some kind of OpenGL visualization of the volumetrics. So that can be a pretty cool way to get an idea what the render is going to look like. And we can increase that to high volumetrics to get some more interesting results. Okay, so that's just one thing I wanted to flag. If you are working with your light and you see that you can actually get some interesting previews much more faster than using Karma renders all the time. So yeah, nice update in Houdini 18.5. Now, when it comes to render, let's export the AOVs, of course, and you can control the quality with these pixel samples. You got the max ray samples for the indirect light, the noise level that will control how much you want to set samples in the pixels, things like that. So pretty classic things. And when it comes to the final output, you can either render with mplay or render to disk, which will just appear in the scheduler. Thank you for watching. Don't hesitate to share your result with me on Instagram, and for each contribution you will win a little prize from my Gumroad. And for the most successful one, you might receive one of my Houdini course. So basically you can learn and win cool stuff at the same time. That being said, thanks to all my Patreons and welcome to the new members. Quick reminder for my new officials and VIP Patreons that the benefits of their pledge is fully starting at the beginning of the coming month. In the meantime, you can still access video tutorials and some of the downloads. Thank you everyone for watching. I hope to see you in the next video. Until then, I wish you a happy learning.